Ben from Dash 9 Computing, and I wanted to talk today about using a captive portal and some of the kind of hackery things we can kind of do with it. I think maybe the best way to talk about it is to just jump right into a really short slideshow. It's about 10 slides, and it'll kind of cover the basics, and I think that'll be a good bar to set, and then we can jump into some code and check it out. Hello, and Captive Portal by Ben Dash. So let's just jump right in. What is a captive portal? It's basically a sandbox that you use to allow clients to connect to your network. Now you can do it with a password, without. A lot of times you'll go somewhere and you'll see, oh, guest network on your phone, for example, and you select it and it will sometimes just sort of let you on. That's just an open network. But when it redirects you, and it'll redirect you either to a web page or maybe to something that looks, official, and it'll often ask for credentials or an email address, or it'll at least tell you, hey, here's the rules. But in our scenario, I want to make it's a captive portal, so you have to log in, give some sort of credentials. If those credentials are met, then you get actually moved from this sort of private network that's very encased to a network that you're allowed to connect to the internet. And there's some notes here. So I used an example of a hotel, and in a hotel, maybe they allow you on with, say, you're staying for the day, and they have a database that will scrape some information like, oh, here's your last name and your room number, for example. Okay, you just log into the portal, put your last name, your last name and the room number, and it says, oh, you're a valid client. I'll give you a 24-hour lease. And then at the end of that time, it'll remove those credentials and you'll get kicked off the network. If you go to try to log in again, if you're not someone staying there, maybe they won't let you back on. That's a kind of a use case. So what do you need to get on the internet in general? Well, you need a client, like a phone, let's say, with a Wi-Fi, or perhaps a laptop with Ethernet or Wi-Fi. Then you connect to this access point, which is like a router switch. You may have one at home, a wireless router. And then what you get back from that access point is an IP address, gateway, a subnet mask, and a DNS server. Now you can hard code these on your devices, but we're talking more about you're just a phone and you're out somewhere and you want to connect. So that is it. And so it uses, sorry, I kind of skipped over this last part. How is that done? How do you get this information, this IP, gateway, subnet mask, and DNS server? Well, you get it from what's known as a DHCP server, which stands for Dynamic Host Control Protocol. The DHCP server listens on a specific port, and when it gets a request, it will say, oh, it can detect what network you're coming from based on the gateway you went through to get to it, and it will check and say, oh, you're here, I'm going to give you these IP address, a gateway, a mask, DNS servers, etc., whatever it's configured to give you. It can decide to give you different things based on different criteria. Perhaps your unique MAC address, that's your interface card, like your Wi-Fi interface card has a unique address to it that is recognizable, and if it has that in this list, maybe it gives you an address, maybe it doesn't. In this case, it doesn't know anybody, and it's just going to try to get some information and then give you a routable address. So when we're inside DHCP, the basic transaction is DORA. So your client comes up and you say, oh, I want to use this network. First thing it does is it does a discover. It sends out and says, hey, I need some network information. And it will either go through the router or through a router, to a DHCP server. Maybe the router itself is running DHCP, which is common. Access points run them. We'll go through those scenarios in a minute. So your client does a discover and says, I need some information. The server offers, oh, I see you're on this network. Here's some information. The client says, sure, looks great. I'm going to request it. And then if everything goes well, the server acknowledges that and you're off to the races. There's a lot of other messages that happen, as I mentioned down here. Renews occur. There's other variables in the options list, lease time, etc. But we won't go too far into that right now. So here's the basic connection. Down here at the bottom, this little blue rectangle is your cell phone. So here's the DORA. You talk up to this access point, and then it discover, offer, request, acknowledgement, and then assuming all goes well in a standard connection, you get a routable address and you go to the internet. So for example, in the DORA here, the client just ARPs out, and or you select it and it ARPs out and gets, it talks to this gateway and it gets the address 172.16.04 with a mask, meaning it designates what kind of how large the network is. And then it also gives a gateway and a DNS at its most basic levels. So the gateway, notice the gateway address is the same as the access point. That way it knows where to send traffic. Gateway, how do I send traffic away from me? I want it to go out to the world. Well, you send it to this gateway. And then a DNS server. This just happens to be Google, for example. And then after that, the client, once it gets this information, it still goes through this access point, but it just goes straight through to the internet. It knows how to kind of talk, and the access point knows it's a client. Now, what we're talking about is a captive portal, a little different. So what do you need to do a captive portal? You need that access point, you need the DHCP server, you also want a blackhole DNS server. A blackhole DNS server basically will respond back to all queries with very specific answers. So for example, I want any DNS lookup to point back to my captive portal. So if you look up Google, you're going to the captive portal. You look up Amazon, you're going to the captive portal, and that web page will pop up the question of like, what's your username, what's your password, etc. So you also need to be running a web server in order to answer that. And you've probably seen this. You go to a coffee shop or whatever, and you tap on it, and it brings up a web page. And no matter what you type, you still get this web page. You have to kind of authorize before you can continue. Okay, so here's kind of the captive portal scenario, and this is sort of the scenario from before, the regular network connectivity. So in the captive portal scenario, here's your client. It does the DORA, just like we talked about, but this time it gets a non-routable IP address, meaning this won't route on the internet, and it could be almost anything really, but the idea is that it's cordoned off, and there's rules that won't allow this traffic to go anywhere other than to this access point. So a lot of access points. In our case, we're using an ESP32, so we're going to put everything on the ESP32. The DHCP server, the blackhole DNS, the web server, the access point, it's all one device. In a larger scale enterprise sort of setup, these would be separate servers typically. So once all that's met, if you meet all the criteria, then it kind of looks like this. Okay, is there a way to get around it? Yes, and then I say sometimes. You can hard code IP addresses in DNS servers if you know the network addresses, or the network range and the network that you're on, and the gateway. You can hard code that information. You kind of need to know it before you get there, so it's not always doable. But if someone's sitting next to you, you can say, what do you have? And you could kind of type that in. I don't know that it's hackery, but it's a way to get around it. A lot of devices are pretty smart now, so they don't allow that. But you can do different things, and sometimes it's not set up very well, and basically all they'll do is give you a blackhole DNS server rather than actually, sorry, let me close this. They'll just give you a blackhole DNS server rather than actually putting you on a closed net. So you can just change the DNS server and off you go. Now down here, I'm talking about if there's an authentication mechanism that uses a MAC address, so that unique identifier on your network interface card on your phone, the Wi-Fi interface, you can change your outbound MAC address. It's easier to do on a computer than it is on a phone, but you can fake it. The other hard part is you need to know a good MAC address that works. This is a doable thing. You could sniff and see what kind of MAC addresses are flying by, but again, those ones are going to be in use. But an example could be you're at a kiosk or something and you look up the MAC address of a workstation. I don't recommend doing this. I want to be clear, not legal or legit or moral, but you could find that MAC address, unplug that computer, put the MAC address on yours, off you go. You're probably going to be fine. You know, I guess I just want to explain that these things can happen so you know they're out there. So here's some other nasty things hackers can do. What if you set up your captive portal and you make it, you know, put some graphics on there and it makes it look like it partners with Google, and hey, you're allowed to log in with your Google credentials. Oh, cool, I'll put in my Google credentials. Well, what it does is it scrapes those credentials, saves them, And then you turn on a sniffer and it kind of sees where you're going. You also have this Google username and password now. And what you do actually, sorry, I should back up, is you get these credentials and then you put them on the public internet. So they're none the wiser. Then the hacker goes and does these things. And through there, you can, you can go through someone's mail and maybe they have a mail from one of their banks or Amazon, and you'll find their username in there and you can try to log in. And a lot of people reuse passwords, very bad. So the password on Google may be the same one as Amazon. And if it's different, a hacker could go in and say, well, I'm going to do a recover password. You put in their username, you say recover password, and most of them send them to their mail. And if it sends it to this Gmail account, there's the password reset. Now, thankfully, there's dual factor authentication. That's where you have a second device. So say you're on your laptop and you go to Amazon, and you go to say, I want to purchase this, but it says, oh, you have to also put in this, dual factor number from your phone, or I'm going to send your phone a message, and you have to say yes to it. That dual factor will prevent this sort of attack from working, because the hacker is not going to have that access, hopefully. If they do, they really own you. So the rule of thumb here, the takeaways are, don't reuse passwords, use dual factor wherever you can, with banks and anywhere you have, credit card information in. So thankfully too, some sites also will ask you for that CCV number off the back of your credit card every time you make a purchase. Enable these things that are annoying, because it's what's going to protect you. And then I think this is my last slide. Don't break the law. This stuff is neat and everything, but do it at home where it's safe. You can get in a lot of trouble. It's not moral. Don't steal. And the reason I'm even talking about it is there's a lot of people out there who are doing this, and you need to protect yourself and understand how easy it is to do some of this and how smooth it can look. I mean, we've all been probably hacked at some point or will be, and it's just getting slicker and slicker. So, use this as a cautionary tale. Learn how to do it so you don't get owned, and just understand the technology. Okay, here we go. The Captive Portal. It's connecting to my Wi-Fi, and it says it's setting up AP mode, and its address is 192.168.4.1. It turns on the async web server and the DNS server, and then it says all done. That's what this version of code is showing. I've been working on having it print to the screen the username and password, things like that. But that's what this one does. So here we go. I go to my Wi-Fi, and I click on the D9C guest Wi-Fi, which is the one that we created in the script. And here it comes up. It says captive.apple.com, DC9 guest Wi-Fi, a little this, a little that, and it says, please log in with your top secret credentials. So we tap on there, it zooms in, type in username, password. There's also a field to do register as guest or employee. You can remove that or whatever, I just put it there. And then it spits back an okay. Now what should happen is it should redirect you now to a different Wi-Fi. That is not working yet, but we'll see where we go. One thing I do want to mention is I ran into some issues where, see how it's under My Networks? Every once in a while I had to go through and click forget this network, and I recommend this if you're doing testing and you're like, sometimes it connects and it won't kind of trigger the next event. Go through and forget it, and it will disappear out of My Networks. And then it'll appear under other networks, and you just click on it and you're back to where you were. I just wanted to throw that in. I needed to do that a lot, to kind of forget my network. Not a lot, but here and there, just to clean things up. So here is the code. The original code I grabbed here, it didn't really work for me. So I changed a few things, which is, it's good code, but I just had to change a few things. And I actually, all truth be told, I did not get this working the way I wanted. It does create the Captive Portal, and it looks like a Wi-Fi access point, and you connect to it as I showed you, and you log in, but that's it. It doesn't spit back the username or password, and it doesn't actually then push you into a new network. I tried, this is like the 8th version. I just can't get it working, so I'll show you what I've done. Maybe someone wants to complete it or take it the next step, but I am I'm stumped and ran out of time. So initially we call the Wi-Fi library. Async TCP, you need that with the web server here. And then this is for the, I'm using the Adafruit ESP32 Feather TFT. So that's what this is, my little built-in screen, and that's the FX library. And then you need the DNS server because it's running a DNS server. Here's obviously for the TFT, and this is SSID and password. You're going to call those later. Here's where we declare the DNS server and the async web server on port 80. You may be thinking, well, where's the port for the DNS server? We actually do that down here in the setup, the void setup. DNS server start port 53, and then here's where we do this. We call on the library the Wi-Fi, I said library, sorry, the class instance Wi-Fi.soft.API, which is kind of a built-in feature with this core for the ESP32. So up here we're setting some more variables. We'll kind of zoom through here. Here's that little web page that you first see when you log in. This is just the title. So down here it says, here it is dashed. I made it color so like blue, red. So -9 computing, Wi-Fi guest, and then the web page. And here's where like the username, password. Here's the little pull down options for guest or employee. So here's we get into something interesting. The class Captive Portal handler and public async web handler. This is, I fiddled with this for so long. My hope was, and I put in some debug statements, my hope was to print out on the serial port in the Arduino IDE, which is right here, and I was hoping it would print it out in there. I couldn't get, it'll print, I know it works, but I can't get it to print inside this class. So here's where it's sort of, here's the request, and it'll do here's a post. So I'm kind of jumping around, but you'll see like here's the /get, and it says like, oh, you're doing the get handle, handling the get. Username, if it's true, the value, receive, password, proficiency, and then here's where I was trying to say, you know, hey, if we get this, if we get all three of these things, the name, the password, the proficiency, or, you know, make the screen black, set the cursor to the upper left corner, make the text green, print the username, login, etc. And then here's these variables above, fill them in with what the person typed. I couldn't get it to work. I've got it working in other scripts, but not in this one. I don't know why. If someone figures it out, let me know. That'd be awesome. Okay, then we say else if method, here's a get for the URL, send them back to kind of the root page, etc., etc. Send a 200, which is like a successful web connection. So here we're into the void setup server. So here's where we do the add handler, more filtration, here's the web server again, and here's where we're kind of talking about like here's the kind of the root directory, and here's the /get. So you hit the /root directory, and this is stuff I wanted to print as well. I tried, yeah, like I said, I tried all these different things to get it to print this stuff. So here you see again, I'm trying to print it again. No dice. I even broke it up into different like different formatting, thinking maybe it was the HTTP response, the HTML wasn't being parsed correctly. I probably should have used JSON maybe. Gosh, now that I'm thinking about it. Okay, maybe it's a JSON thing. And here's the setup. So usually I do this at the beginning, but I put it towards the end. But this is the serial baud rate. And for my ESP32, this fast baud rate is what it likes. And so that's what enables the serial port to print in the serial monitor. And then here I turn on the TFT, initialize it. Why is it doing that? And do some other stuff. And here's the thing where it sort of prints in the very first page, Wi-Fi status, ... and print the Wi-Fi. And then here's the set AP mode and all that. This is the second screen you see. And here it prints what the IP address is. Now, you can set the IP. You can hard set it. I didn't do it in here. I don't know why it's doing that, sorry. You can set it by, but I kind of let it use its own, and it picks this 192.168.4.1. And I was thinking, well, that's good, because I don't want it to be on my normal network. My normal Wi-Fi is 172.16.0, and this is 192.168, so I was hoping the ESP32 would be on kind of serving up on one net, the 192.168, but also be able to connect to the 172.16. That I didn't get working the way I wanted either. I guess that's another thing that I kind of wish I could get going, but it happens. And then here's this loop, which I don't think ever gets called properly. Again, I'm putting it everywhere. I'm like, print the username, print the password, print the proficiency. Just keep trying to print it. I tried it in every section, as you can tell, and I just couldn't get it going. But it is still kind of cool. You know, not everything's a home run, but it gives you an idea of how it works, and I really think maybe someone could use this in a project and do something cool with it. I'd love it. Maybe I'll revisit it at some point. I would like to get it fully functional where it could actually be used, you know, but that's where I'm at. Okay, thanks, bye.